Let's use the contingency table that we created in the previous lesson, showing the two variables, eye color and gender, for a previous AP Stats classes, actually previous statistics classes. The next question you might be asked to find is find the marginal distribution of eye color. Well, key word in this case, the key word in this case is marginal distribution. And I always think of that as meaning look to the margins. So I have two margins. I have my row summary, and I have my column summary. So these values are in the margins. So in effect, when I'm asked to find a marginal distribution, I'm being asked to look at the totals, the total for the rows and the total for the columns. In this problem, I'm asked to find the marginal distribution of eye color. So I have blue eyes, brown eyes, green eyes, hazel eyes, and I want to know what percentage of the students have blue eyes, what percentage have brown, green, and hazel. So in order to complete this problem, I need to be looking at the column summary. So in effect, I'm almost done with this problem. I know I'm looking at the marginal distribution of eye color. So I have the brown eyes. Start with blue. I have blue eyes, brown, green, and hazel. So I can find the frequency of these colors easily just by copying the numbers that appear in my contingency table. We have 10 students with blue, 8 with brown, 4 with green, and 4 with hazel. Usually when you're asked to find the marginal distribution, you want to find the relative frequency or the percentage. So the relative and the total number of students that I have is 26. So often you're asked to find a relative frequency. So relative frequency, 10 out of 26 students have blue eyes, 8 out of 26 have brown, 4 out of 26 have green, and 4 out of 26 have hazel. And we could easily then convert these numbers to our percentages. Next, we're asked to find the conditional distribution of eye color for females. Next, we're asked to find the conditional distribution of eye color for females. So this is asking us to look at one particular group. So we are using the condition female. So we are interested in female students. So we're only interested in this row of the contingency table. So basically, the row that I highlighted has given us our conditional distribution. 2 out of 10 female students have blue eyes, 4 out of 10 have brown, 3 out of 10 have green, and 1 out of 10 have hazel. So my conditional distribution for females I can see that 20% of female students have blue eyes, 40% have brown, 10% 30% have green, and 10% have hazel. And if I did this correctly, my total should be 100%. And we can see 60 plus 40 does give us the 100%. So when you're asked to find a conditional distribution, you are looking at one category for one of the variables. So in this case, I'm asked to look at the category females for the gender variable. Finally, we're going to be asked to look at to determine if two variables are independent variables. So in this case, we're asked, are eye color and gender independent variables? So if they are independent variables, we would expect about the same distribution for each condition. So in this case, let's say we're going to look at female and male, and let's do the conditional distribution of eye color for females, and then the conditional distribution of eye color for males. So we have blue eyes, brown, green, and hazel. We already determined that 20% of our females have blue eyes, 40% brown, 30% have green, and 10% have hazel. We now need to get the relative frequency or percentages for male students. So we're looking at the conditional distribution of eye color for male students. So we can see that 8 out of 16 males have blue eyes, so we have 50%. 4 out of 16 have brown eyes, 25%. 1 out of 16 have green, so around, rounding here, around 6%. And 3 out of 16 have hazel, so that gives us approximately 19%. Now, to determine if these two variables are independent variables, I would like to create a segmented bar graph. So a segmented bar graph will compare two variables. I'm going to have my gender on the bottom, on the x-axis here, so I have females and males, and I'm going to have the relative frequency or the percentage. Never use the counts when doing a segmented bar graph. Always use relative frequency. Therefore, my relative frequency, I'm looking at the percentages. The percentages have to total 100%. So my graph should go up, my y-axis should go up to 100%. So here's 50%, 60, 70, 80, 90, 100%. First we'll do our blue eye. First we'll look at females, and I see that 20% of my females have blue eyes. So my first portion of my bar will go up to 20%. 40% have brown. So I'm at 20. I'm going to add 40% more. So 40% plus 20% will bring me up to 60%. This represents my brown-eyed students. 30% have green, so I'm at 60. Another 30% will bring me up to 90%. And finally, 10% have hazel, so I'll go up 90% plus 10 brings me up to 100%. Now looking at males, 50% of my male students have blue eyes. So 50%, the first portion of my bar for males goes up to 50%. Brown-eyed students, I have 25, so 25 plus 50 brings me up to 75. So 75 is approximately to here. Then 6%, 75 plus 6 gives me 81%. And then finally, 19% have hazel. So the remaining 19 plus 81 is 100%. So both graphs actually do go up to 100%, which is reassuring. I should now provide a key, so perhaps I'll color code. And I start off with blue-eyed students. And then I have brown-eyed students. Brown, I'm just going to continue to be a color of black. Green. And hazel, I'm going to leave plain. Whenever you create a segmented bar graph, you should always have a key. So I'll indicate that this equals blue eyes. And I went off the board. Equals brown, and you would do the same for the green and hazel. So finally, we're asked, are these two variables independent? So if they were independent, it really wouldn't matter if we're looking at the females or the males. We would expect the distribution for eye color to be the same across females and males. But by looking at the segmented bar graph, I can easily see that these are not the same distribution. It's clear that I have a lot more blue-eyed males than females, and I appear to have more brown-eyed females than males, and definitely more green-eyed females. So in this case, I would say that the variables are not independent variables. There appears to be an association between eye color and gender. We have more blue-eyed males than females, and we have more green-eyed females than males.